Alrighty everyone, so this is going to be the video if you're having trouble working through the I do portion and you just keep trying in this problem and you're not sure how to work through it, you can reference this video and scroll to the part or the number you need help with, watch me work through it, and hopefully it can help answer any questions or help you get through a part that you're stuck on to help better prepare you for your test. So part one, question one, again, just like the I do side or the we do side, we are needing to look at our shape, our triangle, finding which corresponding proportions is true. So we need to look at each section and compare to our triangle. Okay, so here WS is going to be our small over WR, so small over small, equals WY over SY. Okay, so we had small over small equals big over this small portion. So this one actually is not going to work out. Okay, so A does not work. B, we're going to look at WX over WR, so big over small, equals RS over XY. Okay, so think about the order in this one. We went big over WR is small. RS, though, is small over big. Okay, in order for this proportion to work, one of these orders would need to be flipped. So B does not work either. Okay, erase this. Letter C, so we have XY, big over RS, small, so big base over small base, equals WS, small base over big base. Okay, remember, in order for it to be corresponding, they have to be big over small would be big over small. So C does not work. All right, and let's check D, our last one. We have small over big equals small over big. In this one, D is the only option that works. All right, so 2B, Ruchier is building, I probably said that wrong. Mr. R is building a 2-story jungle gym according to the plan shown. Find X. Okay, so X is right here. We see this is this small portion. Okay, in order to find X, we need to say, okay, let's look what we have. We have these two small parts, and then we have this long measurement. So I need to think of this in portions. So I can say my big ladder, looking at jungle gym, okay, so 24 over, so big over, we have to compare the other big, okay, so here it's going to actually be 18. So 24 over 18 is going to equal X, my small part here, over 10. These have to correspond. Okay, so once you're here, we're going to reduce if you can, make your life a little bit easier. So 24 over 18 reduces to 4/3. Okay, when we cross multiply, we get 3x equals 40. And then dividing by 3x will be a total of 33.3. Okay. 3b, if the two triangles are shown are similar, find the area of the larger triangle. So we want the area of the larger triangle if the area of the smaller is 390 square centimeters. So area of the larger triangle is going to be X. Remember, when you're working with areas, the ratio, so area of X over the area of, we'll just call this Y, will equal that scale factor squared. Okay, so our scale factor is K. So before we can work with our scale factor, or our proportion, we need to figure out our scale factor. So looking at my two given values, my scale factor is going to be that ratio of change. So if I'm looking at how I set up my triangle proportion, I have X over Y, so I need to go right to left. So we're going to have 21 over 3. right? That reduces to 7 over 1. I'm going to leave this as a fraction because I have to use my proportion later on. So my scale factor is 7 or 7 over 1. Okay, so and now we can work with our areas. So we have x over 390, which is our area of y, is going to equal our scale factor squared, 7 over 1 squared. Okay, so now we're going to have x over 390 equals 49 over 1 squared. So the reason I'm leaving this as a fraction is because you guys will most likely be working with scale factors as fractions. So just for similarity's sake, for lack of better words, we're just going to keep it as a fraction so you are familiar with that process. Okay, so now that we're here, we're going to cross multiply. So we have x equals 49 times 390, which is 19,110. Okay, so the area of x would be this big old number. Okay. Moving forward, for B, if ABC is similar to PQR, find the scale factor of ABC to PQR, so look at the order, ABC to PQR, and the perimeter of PQR. Okay, so we need to find the perimeter of this guy. So first, start with our scale factor. Okay, so scale factor is that ratio of change. Okay, so I have these two corresponding sides. It asks us to go from ABC to PQR, so that's the order I have to set it up in. Okay, so 24 over 9. That can reduce to 8/3. Okay, and then as far as perimeters go, we learned previously that the ratio of the perimeters is proportional to the scale factor. So set that up. We can say perimeter of A over perimeter of P equals our scale factor, 8/3. It is directly proportional. So now that we're here, we're going to say the perimeter of A. Okay, so in order to find the perimeter of A, we need to add all of our sides together. Okay, so perimeter of A, B, C is all of our sides added, so 15, 17, and 24. When you add all of these together, you get a total of 56. So we can say 56 over x, or our missing perimeter, equals 8/3, and then cross multiply. 8x equals 168. Okay, and then dividing by 8, we're left with x equaling 21. In number 5, we have two parallel lines. Okay, we know that when we have two parallel lines, the corresponding parts are proportional. So if AD is 24, DB is 27, and EB is 18, we need to find CE, or in this case, X. So set up your proportions. Okay. We have 18 over 27, so these corresponding sides are going to equal X over 24. Okay. 18 over 27 can reduce. All right, so when we reduce that, we can divide by a common factor of 9. So we have 2/3 equals x over 24. All right, we reduced by dividing by 9. There we go. And then now, just like we've been doing, cross multiply. 3x equals 48. All right, so when we divide by 3, x will equal a total of 16. Okay. For 6b, we have two similar triangles with a scale factor of 5/3. Okay, the perimeter of the larger triangle is 75 inches. what is the perimeter of the smaller triangle? Okay, so 3 things. We have a scale factor, one given perimeter, and one regular perimeter we need to find. Okay, so if you have a hard time visualizing, draw your picture out. We have a scale factor of 5 to 3, so this means your big triangle comes first. Okay, so if you have to draw a picture, big, okay, and small, right? And we have our scale factor of 5/3. Okay, so the perimeter of the large is 75. We need to find the perimeter of the small, okay, big and small. And then just like we did earlier, the perimeter ratio is directly proportional to the scale factor. So perimeter of big over the perimeter of small equals your scale factor. Okay, so plug in your values. 75 over x equals 5/3. Okay, cross multiply. You're going to get 5x equals 225. And then dividing by 5, we are left with x being a value of 45. All right, moving forward. So we need to determine which triangles are similar. Thinking of the similarities that we learned about, we have angle, angle, side, angle, side, and side, side, side. We discussed those in the review video. Okay, so now we're just going to look and say, okay, what information are we given? We have some sides here. We have a set of congruent angles. Okay, so since I know these two sides are congruent to each other and these two sides are congruent to each other, then they would in fact be purple over blue would equal purple over blue. Okay, so we have proportional sides and we have a set of congruent angles. So this is a perfect candidate for side, angle, side similarity. Okay. Next, I have the set of triangles here. We have 3 sides. So if these are proportional, they would be proportional or similar by side, side, side similarity. We need to check the proportions and see if they're the same. Okay, so we have 6 and 8. So 6 over 8 reduces to 3/4. Okay, so that's 1. And then we have a set of 12 and 9s. So I'm just going to check one of these. I have 9/12. That can reduce to 3/4 as well. So that would be the same for these. So since we have the same proportions between all 3 sides, this option would be similar, okay, by side, side, side. Here, the next option, we have a set of sides and an included angle, sides and an included angle. So I need to think, okay, would this be side, angle, side again? Okay, set up your proportions and solve. Okay, so 10 over 15th equals 2/3. Okay, so that's one ratio. And then 14 over 21 would be 2/3 as well because that's divisible by 7. So we have proportional side lengths and 70 degrees, 70 degrees. Because we have 2 proportional sides and a set of included congruent angles, side, angle, side, we are similar. Okay? Last one. Okay? So, let's see. We have a 90-degree angle and another 90-degree angle. Okay? So we have 2 angles that we need to look at. So we're testing angle-angle similarity. Is this similar? So we know for sure we have a set of congruent angles here, 90. So that's one angle. Now we need to check for our second angle. So we have 60 here and 30 here. In order to determine if these 2 triangles would be similar, let's figure out the missing angles. Okay, so 90 minus 180, or 180 minus 90, this guy, would be 90. Minus 60 more would be 30 degrees left over for this angle. Okay, so since we have a 30-degree angle here and a 30-degree angle here, these would be similar. Okay, and that would be by angle, angle. So, in this case, all four of these are actually similar. Okay, so here we need to find the triangle similar to ABC. Okay, so we notice we have sides of 5, 12, and 13, a 90-degree angle here, and a congruent C mark. So we need to look for those similarities between a specific triangle. Okay, notice that this mark of congruency is between the 5 and the 13 lengths. Okay, so when we're going through our options, we have a right angle, yes, 5, 12, and 3, all right? So 3, I can tell you right now, is not proportional, okay, to 13. So these two are congruent, but then the other side is not. So option 1 will not work out. Number 2, we do not, option C. I keep saying number 2, sorry guys. So option C, we need to look for a right angle. This one we do not have a right angle, so nope. Okay. B, okay. We have 3 side lengths. We have a marked congruent angle, so this is a very, very good contender. Let's check those ratios. So 15 and 5, we could say 5 over 15 is 1/3. 12 over 36, that is 1/3 as well. And then 13 over 39 is 1/3 as well. So we have 3 proportional sides, and actually some congruent angles included. So this is definitely similar. Let's check the last one. Here we have a standard 3, 4, 5 triangle. Even though both of these are Pythagorean triples, we'll learn about those next unit, these are not proportional, okay? So the only one that is similar would be option B. All right, and last one, segment BX. Let's call this X right here. Okay, we learned that our special segments are proportional to corresponding sides. Okay, so I can say X over 6 is going to be equal to 32 over 10. Okay, I'm going to reduce this fraction. So I have X over 6 equals 16 over 5, because you divide this by top one by 2, right? When you cross multiply, you have 5x equals 16 times 6, which is 96. And then when we divide 96 by 5, we get a total of 19.2. Hopefully that helped you work out through the assignment. If you have any questions, please do not hesitate to reach out. Great job as always, and good luck on your test.